Hi, I'm Josh Ebner. Welcome to the PSEG Long Island Home Comfort Whole House Residential Heat Load Calculations Training Series. As a home comfort partner, you'll find this series an invaluable guide for properly sizing and selecting mechanical equipment for participation in the home comfort program. In this segment, we'll be reviewing Elitesoft, RHVAC software. Now, this is a screenshot from Elitesoft. This is where you would go to purchase the software. It runs around $499, and they can ship you a thumb drive. There is an online version as well, but we're going to today run through the Windows-based version. When you first open the software, there's a bunch of there's a toolbar across the top. You're going to see new project. You're going to see icons that look like this, and these are sample templates that they give you. This is a sample DB, which means drawing board, and you really want to start out not using the drawing board. That's a little bit more advanced. You want to start out using the room data entry method, and that's the method we're going to talk about today. So when I first open this software, I usually pick a sample if I haven't ever done one before, and then you're going to take that template and start to fill out the information you need on that template. So you're going to start with general project data. We need the project title, usually the customer's name, designed by your company, current date, if you want to add any comments. It's important that the orientation of the front door is correct. So it has a lot to do with the solar gain, if front door is facing north or south. It's also something we check when they get submitted. Design conditions, you're generally going to run into 3 different locations to choose from. I mean, there's thousands of locations to choose from, but the 3 I commonly see is Central Islip, LaGuardia, and Gabreski Airport. So as you're, either further west or further east, you can choose either of those. If you're in the middle, Central Islip is a good choice. You want to make sure it has the ACA MJ8 stamp next to it, and all 3 of those do. At the end of the general project data, you get to your duct sizing, and you generally just leave this tab alone. Let the software calculate the main trunk runouts. The other tab you're going to start with is default room data. So the software allows you to enter this default room data for commonly used building assemblies. So if you have a house that's a 2x6, R11 in the walls, and common ceilings that you see of houses in your area, you would enter those assemblies in here. And then when you're on the room data window, you just quickly hit a button that says copy default room data. So it allows you to quickly bring in default room data into your room data window when you're changing one of the manual J calculations. This is an example of floor material window selection. So you'll see there's 4 basic choices here. Most of the time you're going to be over an enclosed crawl or basement. Sometimes you'll be slab on grade, but as you click on these, and we're going to run through a live demo in a little bit, but as you click on these, you would then choose from choices below, and it gets more and more specific as you go. And this is showing the default room data box pretty much filled out. You got your floor materials. It has the U value already populated in there. You can enter a room height. You really don't want to enter a width and a length in the default room data because that's going to change. But your height, generally 8 foot, is for most projects. Common glass material, and it lays out exactly what insulation you have for these numbers. And these are common numbers across all software, RightSoft, Elitesoft, they all use these same ASHRAE numbers for building assemblies. Now this is the room data windows, the window that you're going to live on most of the time. And this is where you enter your number of rooms. We're on the family room right here. Here is the toolbar across the top. You can switch from room to room here. You can add a room. This is where you would bring in the default room data here. You can cut a room out. And all these have help features too. So if you weren't sure what this is, you click on help and it tells you. The program is very intuitive. So we see on this, we have 120 by 16, 8 foot tall, floor material, wall material, roof. We have glass. We have 2 people in this room. We're going to get into this side in a little bit. The other thing you want to enter for these calculations is the appliances, things like refrigerators, washers, dryers, coffee makers, microwave. They all have BTUs associated with them, so you want to make sure you have a good package of normal appliances in there. I mean, if you have a house that has extra freezers in the basement, you should add that in. Do as much as you can. It tells you how much BTUs for each one that you're adding, and you can add them and delete as you need. So this is an example, a screenshot. Brian's adding a family room here. This is a system data window. So this is one of the important windows that's going to cover the infiltration, the equipment type. It covers the duct load factors. Once you click on this infiltration button, you're going to be brought to a screen like this, where they're going to ask you to guess how leaky this house is. And this is probably one of the more important parts to the Manual J, because how leaky the house is really dictates how many BTUs you're going to need to heat and cool it. It's got your fireplaces here, so make sure you don't forget to add a fireplace. He's got this house at tight. Exposure options, 3 or 4 exposures, single story. So it'd be like a typical ranch house. It's 1,500 square feet. And he's got it at tight, 1 fireplace. There's his air changes per hour, 0.14, calculates all that for you. If you happen to run a blower door test, like some of the home performance contractors can do, there's a method where you can actually enter the actual air leakage that you've recorded with your blower door test. That is the best way to do it. If you need help, we can help you figuring out how to enter that data. The other important part besides infiltration here is duct load factors. So right here is where you're going to click to enter what kind of duct system you have in the house, if there is a duct system. You want to make sure you have the location right. Attic ceiling type gets pulled from the room data window that you just filled out. The duct leakage rate is something that you're going to guess at as well. It's usually tight, semi-tight, loose. Your duct insulation R value, 4 or 8. And then there's a way for it to calculate based on the square footage of the house, how many square feet of duct you have. You can add the number of returns. If you did 2 or more returns, say return in each bedroom, that adds to the amount of duct work, and you can enter that and the calculator will spit out a larger number for your duct surface area. This is where the tab where you would pick what report to send to us. We do want the title page. We want the project. We need those 2 pages for sure. The load preview page is good to send us. You don't need to send us any duct size previews, but really that title page and that project will give us basically all the information we need. So this is that project page, designed by customer's name. He's got LaGuardia here. We're going to look at the outdoor winter and summer design conditions. So these are the temperatures. They call them the 99% and the 1%. So it's only colder than 5 degrees 1% of the time, and it's only warmer than 91 1% of the time in LaGuardia. So we also tend to look at square foot per ton. So this one's coming in at 580. That's pretty much average. You don't want to see anything below 400 square feet per ton. That kind of throws up a red flag. And then the numbers that you enter onto your worksheet from the Manual J are right here. So total heating required. This house needs 51,294 BTUs to heat it on a 5-degree Fahrenheit day. And it requires 37,598 on a 91-degree day. So you take those 2 numbers, enter it on the worksheet. And for this house, for it to be a whole house passing project, you would have needed to install a 5-ton air source heat pump. Roughly anywhere between 55,000 and 60,000 BTUs could heat this house on a 5-degree Fahrenheit day. This is one of the room load summary tabs that you're going to see. It has a nice breakdown. It shows how much the ductwork BTUs come in at. Master bedroom BTUs, breaks them all down. It has that sensible latent split here. So the latent is the amount of moisture in the air, and the sensible is just the temperature that you feel. So both of those numbers come together to give you your total BTU. Now, total BTU is always what we are going to enter on our worksheet. The software does come with manual D. It's a tabular manual D. It's not something we're going to talk about today, but you can see you kind of just add runouts. I mean, you have your main trunk, your system, main trunk line, and then each of your individual runs to each room. There is a way, once you've created your tabular manual D, to override the default Duct BTU. So you would hit this little button here, TMDD, use the tabular manual D, and it enters the actual manual D information back into the manual J report and updates the BTU required for that ductwork. The last thing that comes with the manual J software package is manual S, and this is regarding the expanded system performance data. So the manual S will tell you your system size, if it's too small or too large, depending on data that's outside the normal AHRI range. So AHRI is at 95 degrees cooling, but it's not always 95. Like our manual J at LaGuardia was 90, 91. So the manual S will help you determine make sure you're not oversized on the sensible and the latent side with your equipment selection. Thanks for watching. To see this whole series and to access additional helpful program content, be sure to visit us often at PSEGLINY.com.